Howdy everyone, welcome back to the Country Chemist. As the school year is starting, there's a lot of need for things to be covered in geometry, algebra, trigonometry, pre-cal, and in physics. In this video, I plan to cover the 30-60-90 triangle, the 45-45-90 triangle, briefly discuss trigonometry, and then show how this relates to the unit circle. To begin, let's discuss the special triangles, special right triangles. Okay, so this first one's a 30-60-90 triangle. So let's assume this angle here is 30, as it is smaller, and this one at the top is 60. This is 30, and this is 60. Then the side lengths are as follows. Across from the 30, we call this x. Across from the 60, we say x square root of 3. And across from the 90, we say 2x. This is the special case for the 30-60-90 triangle. Also note that across from the smallest angle, we get the smallest side. Across from the middle angle, we get the middle side. And across from the largest angle, we get the largest side. That is a property of triangles. For the 45-45-90 triangle, so these two are now the same angle, that means both of these should be the same. If this side length is x, this one must also be x, and this must be x square root of 2. And this has a lot of implications. In general, this can make a lot of math simpler, and I'll be showing that in future boards. So let's just make an example real quick. If you have a 30-60-90 triangle, let's try to draw one out. Oh, hello. For whatever reason, it decided to be black in the inside. That's fine. Okay. So let's say we have a 30-60-90 triangle, and this side length is equivalent to 4. Then this is 4 times the square root of 3. And this side length is 8. Let's do one more. Okay, interesting. This time it trimmed it in blue. That's fine. Okay, let's say this side length here is 4. Then what else do we have? If this is 4, 4 equals x square root of 3. Meaning that if I were to set this equal to x square root of 3, and we were to solve for x, means that x equals 4 divided by the square root of 3, which is often rewritten in another form because we do not like seeing square roots in the denominator. So we'll multiply it by the square root of 3 over the square root of 3. And we get 4 square root of 3 over 3. So this would be our short side. And if this is x and this is 2x, then here we have 8 square root of 3 over 3. So there's two examples of putting this to use. So let's take a look at the 45-45-90 triangle for a sec. Okay, if we have a 45-45-90 triangle, and this side is, let's say, 4, then this side is also 4, and this is 4 times the square root of 2. It's pretty easy. Let's say we have another triangle, and this time the hypotenuse is equal to 8. Then if 8 equals x square root of 2, then x is equal to 8 divided by the square root of 2. But this format is not preferred. So we would multiply both the top and bottom by the square root of 2. And we'll get 8 square root of 2 over 2, which equals 4 square root of 2. So 4 square root of 2 is what we'd put for both of the legs of this triangle. Okay, let's finish this up with two more examples, which will come in handy in a little bit when we get to the unit circle. Let's say we have a 30-60-90 triangle, but this time the hypotenuse is 1. So 1 equals 2x. This means that x equals 1/2. This means that the other side, the one across from 60, is the square root of 3 over 2. This will come in handy later, understanding how to do this. Okay, and for the other example, if we have a 45, 45, 90 triangle, but in this example, the hypotenuse is 1, which means this equals x squared root of 2. Thus, this side is 1 over the square root of 2. Or, when we multiply the numerator and denominator by the square root of 2, we get the square root of 2 over 2. And this is the side length for both the legs, square root of 2 over 2. If the radius or hypotenuse is 1. We will come back and use this later. Just keep it in mind. Now let's go in and talk about trigonometry. Namely, what does sine, cosine, and tangent mean? You might be familiar with the acronym Sohcahtoa. If not, you'll be learning this right now. And this will be a great way of remembering this. Okay, so sine of an angle, which we'll call theta, equals the opposite side divided by the hypotenuse. Sine equals opposite divided by hypotenuse. Cosine of an angle equals the adjacent side divided by the hypotenuse. And the tangent of an angle equals the opposite side divided by the adjacent side. Okay, so let's put that to use. If this angle here is theta, and let's say this is A, let's say this is B, let's say this is C, then the sine of theta is equal to the opposite side divided by the hypotenuse, or A over C. If we ask for the cosine, and cosine of theta equals B over C. B is the adjacent side to that angle, is the side right next to it. And if we ask for the tangent of that angle, we will get the opposite side divided by the adjacent side, or A over B. Okay, so this is all nice, but there's another use for this. If we decide there is another use for this. If we talk about arc sine, arc cosine, or arc tangent, also written out as sine -1, cosine -1, and tangent -1. If we write them out like this, arc sine, arc cosine, arc tangent, or some people like to say inverse, although I don't personally like the word inverse, but that's okay. If we write them out like this, and I put in A over C, as in I type in this fraction, my calculator will tell me what theta is. This is very useful. Okay, so A over B, and this equals theta. So this is a very useful thing that you can do to figure out what the angles are. Okay, additionally, let's go ahead and call this another symbol. Let's just use x. If I say let's do the arc sine of B over C, the only thing that this is opposite to, since this is opposite over hypotenuse, is x. So the angle that my calculator will tell me is x. Or we can do the arc cosine of A over C. We can get x. And last, we can do the arc tangent of B over A and get x. So as you can see, you can learn a lot about right triangles from basic trigonometry, understanding sine, cosine, and tangent, and how to use that on your calculator. Additionally, it's worth noting whether your calculator is in degree mode or radian mode. If you're measuring in degrees, it has to be in degree mode. If you're doing radians, it has to be in radian mode. We'll talk about that shortly, how those two differ. So let's go ahead and talk about the unit circle. The unit circle is a circle with a radius of 1. We use this circle in order to understand what radians are and shortcuts for trigonometry. Let's go ahead and talk about this real quick. If the radius is 1, then the circumference around the circle is 2 pi. So one full trip around the circle is equal to 2 pi. Means halfway around the circle is pi. Half of that is pi over 2. Meaning that this must be 3 pi over 2. And then we can break this up. Half of that, which is where 45 degrees would lie, is pi over 4. And then since we talked earlier about the 30, 60, 90 triangles, we're going to include that so we can talk about that as well. If 90 degrees, well, let's go ahead and talk about that real quick. 360 degrees is equal to 2 pi radians. So this is the difference. If you typed in 6.28 on your calculator and you were in radian mode, your calculator will treat it as if you had 360 degrees typed in degree mode. So if 360 degrees is 2 pi, 180 degrees is pi, 90 degrees is pi over 2, 45 degrees is pi over 4. So then let's talk about what 30 degrees is. 30 degrees is a third of 90 degrees. So 30 is pi over 6. So 60 must be 2 pi over 6, which is pi over 3, pi thirds. And this pattern continues. 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, which reduces to 2 pi thirds. So there's 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, which reduces to 4 pi over 3. So it's 8 pi 6, 9 pi 6, 10 pi 6, which will reduce to 5 pi over 3. Then we have 11 pi 6. And finally 12 pi 6, which is 2 pi. Here we have 4 pi, so this is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. This is 6 pi over 4. This is 7 pi over 4. And this is 8 pi over 4. And since I want to be consistent, I can also go ahead and put a 0 in here. So let's go ahead and write in another measurement. Okay, this is equal to 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120. This one is 150. This is 180. This is 210. It's much easier if I count by 30s the entire time. This is 240. This is 270. This is 300. This is 330. Okay, let's go ahead and fill in the rest. 90 plus 45 is 135. Plus 45 is 180. Plus 45 is 225. Plus 45 is 270. Plus 45 is 315. And plus another 45, we're at 360. There we go. Now we have a way of getting from radians to degrees. Do note they are measured going counterclockwise. That is important. Okay, so where does the 30, 60, 90 triangles come in? So let's talk about that real quick. If we make a 30, 60, 90 triangle right here, we know that the radius is 1, and we did mention this on the other board. If you're in a 30, 60, 90 triangle and the radius is 1, the short side is 1/2, the long side is the square root of 3 over 2. the short side is 1/2, the long side is square root of 3 over 2. So this is equal to the square root of 3 over 2 and 1/2. And due to symmetry, if we reflect over here and look at the other side, we see that same triangle. But this time, x is negative and y is still positive. What if we go down here? Then x and y are both negative. So at this point, we have negative square root of 3 over 2 and negative 1/2. And we can continue this pattern. If I moved here, actually let's go ahead and talk about that then. No, let's continue. Okay, and that pattern continues. On this side, x is positive but y is negative. So this point is square root of 3 over 2 and 1/2, negative 1/2. Okay, what about at 60 degrees? It's the same triangle, but at 60 degrees, the short side is x and the long side is y. So we flip it. This is 1/2, the square root of 3 over 2. And then we can do that same pattern everywhere else. Here x becomes negative, so negative 1/2, square root of 3 over 2. Down here, y becomes negative, so it's negative 1/2, and negative square root of 3 over 2. Then here, x is positive, so we have 1/2 and negative square root of 3 over 2. So far, so good. So just notice, the first quadrant, x and y are positive. The second quadrant, x is negative, but y is positive. The third quadrant, both x and y are negative. And then the fourth quadrant, x is positive, but y is negative. Okay, let's also fill in, well, I guess I didn't do this, so let's go ahead and do this as well. This point here, at 0 degrees, is 1, 0. Radius is 1, so it goes out 1, but it has no height to it. At the top, we have 0, 1. Here to the left at 180 degrees, we have negative 1, 0. And here at the bottom, we have 0, negative 1. Cool. Now let's do all the 45s. Let's go back and look at that. A 45, 45, 90 triangle, when the radius is 1, the side lengths are the square root of 2 over 2. Okay, so here we have the square root of 2 over 2 and the square root of 2 over 2. Here we have negative square root of 2 over 2 and positive square root of 2 over 2. Notice x is negative, y is positive. Down here they are both negative, square root of 2 over 2 and the square root of 2 over 2. Negative. Okay, and here x is positive, but y is negative. Cool. So now we've done the entire unit circle and we have all these measurements. But what does this tell us? As we mentioned before, sine of an angle is equal to the opposite over the hypotenuse, and the cosine of an angle is equal to the adjacent over the hypotenuse. The hypotenuse of all these triangles is 1. So as far as I'm concerned, this cancels out because it's just 1. Means the sine of an angle is equal to the opposite side, and the cosine of an angle is equal to the adjacent side. Let's go one step further. The opposite side is always y. So sine of theta equals the y value, and the cosine of theta equals the x value. So let's put that to use. If you were to type into a calculator cosine of 0, then at 0 your x value is 1. It's going to tell you 1. If you typed in cosine of 30 degrees, your calculator will tell you the square root of 3 over 2. Actually, it will give you the decimal approximation of it, but go ahead and try that out. Type in cosine of 30 degrees, it will give you a decimal. Then type in the square root of 3 over 2 and see if that decimal is the same. If it is not, you might be in radian mode, in which case, if you type in cosine of pi over 6, and you're in radian mode, it will tell you the square root of 3 over 2. Let's move further. What if I said sine of, let's do 225 degrees? Then your calculator is going to tell you negative square root of 2 over 2. Well, it's going to tell you the decimal approximation of this. So there's your big takeaway. If you learn the unit circle, then for any multiple of 30 degrees or 45 degrees, you can quickly come up to the answer without using your calculator. The unit circle teaches you what radians are, and when you get into physics and you start talking about angular motion, radians are vital to doing those equations very quickly, as degrees don't translate very well. Radians are a direct measurement with how far the circumference has traveled if the radius was 1. So if the radius was 2, then you traveled 4 pi. You multiply the number of radians by the radius, it will tell you how far you've traveled if a ball or a gear was rolling. This is a very helpful chart to use in math and in physics. And I hope this really helps you understand this. The cosine of an angle gives you the x value at that angle. The sine of an angle gives you the y value at that angle. I think that's remarkable and a very nice way of learning how to do this. If this has helped you, please hit that subscribe button. I will be sending out more videos like this in the future over other topics. If you have any questions, please leave them below. Thank you for your time, and thank you for watching.